Hello? Hello, this is a test to see if this works. Hello, this is a test just to see if this works for a second. Shutting it off now. Good evening, everybody. My name is David Ecker, and welcome to WolfieTank 2021. I'm the director of iCreate. This is our 6th annual WolfieTank. We started this many years ago with building a department where we wanted to foster innovation and entrepreneurship on campus through a cross-disciplinary approach. Today, I welcome all you for the first time for our virtual event. We're excited about being able to broadcast to you wherever you are at this time. It's been a real difficult year, and we hope this year's event can help bridge the gap between where we were and where we plan to be in the future. We wouldn't be here without thanking a few of our colleagues, partners that have worked tirelessly behind the scenes to make this event occur. Robert Kutta, the Acting Dean of College of Engineering and Applied Sciences. Garrett Wolf, the Director of the Innovation Center. Richard Chang, the Director of the Center for Entrepreneurial Finance. Vincent Accardi, the Assistant Director of Development for College of Engineering and Applied Sciences. Manny London, the Dean of College of Business. Michael Aspatale, the Assistant Vice President for Customer Engagement and Support. Also, a big thank goes to our partners. Solder Technologies, Markham, IV Matters, Softion, and Balsamic for all their help in putting it all together. So the format of tonight's event. So you know, we were a little concerned about internet stability. To mitigate this, I'm broadcasting from Stony Brook University on a wired connection. We've also had all our presenters pre-record their presentations, but the judges and nobody else has ever seen these before. All our presenters are here live, and you could see them when they turn their cameras on or wave to you. And they'll be answering their questions live as you see it. We also have live comments going on YouTube, and they'll be able to chat with you with our experts who are moderating and be able to send me questions if things come up. Thank you all for coming, and without further ado, let's get started. First, I would like to introduce our judges. Derek Peterson, the CEO and founder of Solder Technologies. Peter Chakrabarty, client partner of Fractal Analytics and entrepreneur. And Bob Williams, president of IV Matters. My virtual handshakes. They have extensive knowledge and expertise in entrepreneurship, and their feedback is always invaluable to really helping our future entrepreneurs at Stony Brook. Our first presenter is Active Site.
Hi, this is Jason, along with Nate, Brendan, and Theo. In this presentation, our goal is to make it possible for visually impaired people to exercise on their own and improve their mental and physical health. Our product's usable by individuals, but can also be utilized.
All right, 1 second. It looks like we're having a presentation with the audio. Let me see if I can fix that. Hold on 1 second, everybody. My apologies.
Hi, this is Jason, along with Nate, Brendan, and Theo.
In this presentation, we'll be introducing ActiveSight, a product that will help the visually impaired.
Before we begin, I'd like you to put yourself into the shoes of a young, visually impaired athlete. Think about how the physical exercises, such as running and swimming, could be difficult and scary with reduced or even absent vision. Evidently, these impairments can make it difficult for affected individuals, especially children and teens, to exercise, leading to a deterioration of physical and mental health. We found that there's a lack of progression in affordable technology designed to make exercise more accessible for these people. Our goal is to make it possible for visually impaired people to exercise on their own and improve their mental and physical health. Our product's usable by individuals, but can also be utilized by summer camps, namely Campabilities, a Long Island summer camp for visually impaired children and teens. On the right, you can see our device is a wearable distance detection device that uses ultrasonic sensors to map potential obstacles, determine distance to said obstacle, and provide the wearer with sensory feedback, such as vibrations. It can also be paired with a web app.
Currently, ActiveSight is in the development phase. In this phase, we have developed a web application in collaboration with Long Island Campabilities. In addition to this, as mentioned in the previous slide, we have developed a prototype for the hardware that will pair up with the web application. In the next 2 years, we plan to continue to prototype and improve the functionality of our hardware and software and minimize the cost and scale up. By 2024, we expect to introduce ActiveSight at a Campabilities Big Summit event and expand the number of partners that we have.
For marketing and customer acquisition, this is a heat map that represents visually impaired individuals per state, namely California, Texas, Florida, and New York. This heat map represents our primary source of traction, which is the visually impaired, but we're also including active individuals. Our secondary source is pursuing the partnership with Campabilities that was previously mentioned, as this lets us get our foot in the door in many pre-established locations that have pre-existing clientele. On the right, you see our customer life cycle, which is largely based around advocacy. This is a close-knit group that wants to spread the good technologies that assist them in their day-to-day lives and are very willing to do so. For our business model, we have two halves, hardware and software. Within hardware, we have direct purchase of hardware, and we have warranties associated with that hardware if the purchasers want to pursue one. We also have technical support, which is more oriented towards enterprise-level users, but we can also use it for individuals. For software, we have subscriptions for higher tiered software, and we also have different versions, enterprise and personal.
So here are some existing similar device to the one we are doing. From left to right, the first one is a visual enhancement device that cannot detect obstacles. The second one is health monitoring watch, but it cannot detect obstacle as well. The third one can actually detect obstacle, but it's not on the market, it's only for research. So we are the only one that can do all this function for visually impaired people. And based on the patent criteria on the right, we are definitely able to patent our device.
For our financial projections, we're seeking a potential funding of $200,000. This will help see us through our first 5 years after we enter market. Our manufacturing cost per device is just north of $43 with a sales point of $180. When you compare this to the Apple Watch, which is a close competitor, you can see that we are fairly affordable when you compare them. This sales and manufacturing difference gets us a margin of profit of 76%. And we have just under 6,000 users after 5 years, which gives us a total profit of just about $800,000.
This is what we have so far. ActiveSight is currently funded under a small seed grant from Stony Brook's engineering department. This grant is used to help us buy and prototype some of the hardware components that go into the final product. We have also developed a wearable design in collaboration with members of New York's Fashion Institute of Technology for Campabilities track and field activity as shown in the bottom left of this slide. As we develop the wearable design, we have plans to make the design more compact. Finally, we have designed and deployed a progressive web application specific for Campabilities. You can see how a coach from Campabilities interacts with a visually impaired athlete and their data, and the GIF in the middle. This application will be able to pair with the hardware and record data as well as send any live alerts that the hardware captures. The end goal of the application is to perform data analysis and also ensure the safety of the wear. ActiveSight currently requires the necessary funding to buy components for the hardware, the maintenance of our software such as a hosting service, and sales representatives. We plan to derive potential funding through small business grants that fund wearable devices that support the visually impaired. We also plan to utilize health funds to allow visually impaired people to purchase our wearable device at a discounted price. And thank you for listening to our presentation. Do you have any questions?
That was Active Sight. Now I'm going to turn to the judges to see if they have any questions or feedback they can share. Depita.
Yeah, hi. I have 2 questions. First is, how are you thinking of operationalizing it? You're looking at US as a big potential market. You know, these things probably will require quite a bit of, you know, marketing, you know, getting the product and the knowledge out and all of that. I didn't hear enough about how does this become a full business. I understand the development of technology.
Right. So for this, we're focusing first on capabilities, which is it's one base is on Long Island. It's a visually impaired summer camp, essentially. So from there, we already have clientele in Long Island capabilities that are using a prototype of the device. From there are several other capabilities locations that we plan to expand to, and then just grow out from communities like that. A lot of the kids will go back to schools around them, and they'll be able to spread the new device that they're wearing, hopefully to school, maybe to go to gym class, to other blind individuals or visually impaired individuals that aren't using our device currently.
Okay, so through camp and then word of mouth.
Yeah, so through the camp is how we're going to get our initial foothold of users. After that, we'd have to hopefully rely on our sales representatives and go through marketing in more typical fashions. But the camp is really our primary idea.
And perhaps you already touched on it and I missed it. How much extensive testing have you done to say that it works under all circumstances, since your anchor point looks like is the barrier detection feature?
So far we've done, sorry.
Oh, yeah, Nathan can take this way.
The device that we have so far is not a full complete device. We have done testing with a small prototype. So right now we wouldn't be able to send somebody out there in a track and field race wearing this thing. But right now it's more we have the technology and are working to improve it to the point that we can actually put it on somebody and they can be confident knowing that they're not going to get injured while using it.
And to add on to that, we've already done some testing with capabilities last summer with our web application. And we've already been able to log a lot of data of the visually impaired athletes that attend capabilities. And this data will be eventually used for data analysis.
I know it must be promising since you're pitching today. Are there any technical barriers that you're looking at right now, looking to solve?
Currently, we're looking at issues with the actual distance detection method. There's a couple different ways to do it, and right now our device uses ultrasonic sound waves, which is having a range issue because we're finding that it's not very long range, and we're looking into more technologies like LiDAR, just like light imaging and ranging technology, and other time of flight, other sorts of technologies that could give you a longer range than what we currently have.
Okay.
A better, this is Derek Peterson, a better solution, you know, ultrasound's not going to give you the solution you want. I advise you to look into LiDAR, time of flight. That would definitely help you get to where you want to go to. But my question is going to come down to, in your manufacturing estimates, you projected a price cost, so that's going to cost you roughly about $43 per device to make. Is that correct? Did I read that right?
That was when we were looking at ultrasonic sensors. So the ultrasonic sensors are very cheap, and we only need the Arduino and the ultrasonic sensor.
So you're going to go to market with, there goes another question. So it looks like you're going to go to market with an Arduino running it?
That's what we have right now, yes.
So ideally, we would be able to trim that down to a printed circuit board. So it'd be a customized circuit board as opposed to an all-around Arduino that can handle anything. We want to make it specialized.
That's what I wanted to hear. You want to make it specialized. Have you done any studies about power management, battery life, what it's going to rechargeability of the device?
So currently we're running it off of AC power. So we're plugging it basically straight into a wall. It's currently not portable enough that you can like throw it on your wrist and run around with it. So it's still in the prototyping of, we're not worrying about battery life. Although we do want to make it long enough where you can wear it like an Apple Watch, where you can not worry about charging it overnight and you can still use it the next day.
Okay, so the form factor you're thinking is going to be like, it's not going to be an Apple Watch form factor. It's going to be like a harness that we're around them, correct? Did I see that right?
Yeah, sorry. I was using the Apple Watch more as like a euphemism for just being able to put it on quickly and just get going with your day.
And what health vitals will you be taking from this? Because I saw one of your slides, you mentioned you'll do health vitals. So what vitals will you be taking?
Right. So we'd ideally want to be able to take heart rate would be the biggest one because we're an active company, so we want to monitor that. Outside of that, it can be expanded into other, I guess, ideals associated with blood. So maybe blood pressure would be a thing depending on how the device is strapped up to the user. But we need to expand on that idea a little bit more, I think. But the heart rate's our biggest one because you want to be able to make sure the user is always within like a safe threshold or even a healthy threshold for being active in their gym class. You want to make sure they're getting their heart rate up above 180. We also want to be able to do location. So if your child's out running in like your backyard and you can, let's say you check your phone on a companion app and you want to make sure that they're not, two yards down, still doing their activity. You want to make sure that your kid's safe.
Okay. Right, fair enough. I'm not going to hog everything. Bob, you might want to say something.
Yeah, very nice presentation, gentlemen. Just a couple of clarifications. First is, would you look at having this device front-ended by a smartphone to basically act as the interface between your range sensing device? Or is this something that's going to be completely standalone? Because you talk about a software application, so I'm assuming are you going to go the full route of making it a full-blown IoT kind of device?
Right. So I think Jason might be able to handle this question.
Yeah, right. So our current application works on the web. So it's a web application that technically any device could run. Our goal is to have it on a mobile device like a phone. But right now it could be run on theoretically anything like a laptop or anything with a Bluetooth connector. And to answer your question regarding if we plan to have this fronted on a specific device or have our own ecosystem or something like that, we do plan to have our own ecosystem when we're developing this device, because really it's just a website that you connect the hardware to, and then the website starts to log your information.
Okay. Just a little bit of a comment. You're looking for a $200,000 raise. I'm not familiar with the market. I think you have a very noble cause you're trying to chase, and I really want to wish you the best of success. You're asking for $200,000 to sort of intimate you're going to be a production. I think clearly this is a big market. I saw in one of your slides, it looks like there's about 800,000 people with visual disabilities that could use this. I think the 200,000, I think you should maybe think about taking that money and really getting you to what I would say the next level prototype. Right now, you're at a concept stage, getting it to what I would say minimal viable product that you could really think about, going to market with, do your customer discovery on. Another market segment I would not leave out of the picture with this is obviously younger people with disabilities, but don't leave out the seniors as well. They have a lot of visual issues, and they need their exercise and so on and so forth, and to keep active. So anything that can make these individuals' lives better and them healthier, I fully support, and I wish you a great amount of luck, but really try to get to that minimum viable product as the next step.
Thank you.
And I have one more question for you. So you're actually venturing into the healthcare market. Have you thought about, you're probably going to need an FDA approval on this? Have you thought about that?
Right. So something that we have considered. Also, I want to make a quick note about Bob mentioned our market size. The visually impaired market's actually roughly around 12 million people. So we have a fairly big market cap on the individuals. But I'm addressing more of the health impact. We are aware of how liabilities and such like that. So we plan to have individuals sign waivers when they purchase our product, saying that the liability doesn't rely on us. We'll have statements involved. As far as FDA approval goes, I think that we don't need to get specific FDA approval since it's considered a wearable technology. Like an Apple Watch, I don't believe needs FDA approval. But if we're involved with heart rate, we definitely want to look into that to make sure we're not violating anything major as far as regulations go, because that's kind of a big no-no. You don't want to cross that.
I would give you the advice to definitely check into that. I live in this world all day long with our medical devices, and we have sensors that do heart rate, respiration rate, blood oxidation level, and so I'm dealing with the FDA on a regular basis, and you're right on that fringe where you probably will need eventually a 510(k) approval.
Okay. Yeah, we definitely want to make sure of that.
Thank you. That was great back and forth. Now we're on to our next presenter. IOREM.
Hello everyone, we're IOREM. Imagine that your significant other is in a severe septic shock when they are rushed to the ER. Physician notices collapse of venous system, thus resorting to intraosseous or IL. There are three sites where the needle could be inserted, labeled 1 in the diagram. The IO needle set is drilled into the site and start infusion of medication. This is an emergency procedure that saved your significant other's life when the veins were not accessible. The IO needle needs to be removed. Current practice uses a standard Google lock syringe where the physician stabilizes the patient and yanks out the needle while twisting and maintaining a 90-degree angle to the bone. Physicians are hesitant to use this method due to a serious risk of removal, such as needle stick injury. Our device tackles two main criteria: safety and accessibility. Throughout the process, IO needle is encased, significantly decreasing the possibility of needle stick injury. The design is straightforward and easy to use with limited force required. Given its safety and ease of use, physicians will more likely use IO procedure.
Our development plan consists of 5 stages, and each stage includes our plans and timeframe. The first stage we already completed is where we designed the device and created a prototype from it. The second stage is where we worked on a provisional patent, and the third stage is under progress, which includes production and cost, where we have finalized our design and make sure all the functions and its costs are viable. For our fourth stage, we will push to finish all testings and create a professional final product before meeting with a patent attorney and submit our patent. And for the final stage, it is to market our product and find investors.
So where is the market? 1 to 2 procedures are done daily at Stony Brook Hospital. This means that close to 4.5 million procedures are done annually in the US alone. As Amr had mentioned, IO access procedures are still underutilized by physicians across the country. We are optimistic that our device will allow doctors to feel more comfortable with the entire process. Currently, if patients are out of network or uninsured, they have to pay anywhere from $400 to $500 for an IO access. If their insurance is accepted, the increase will decrease slightly. However, these numbers pale in comparison to the overall cost of care. Moving on to our business model, we aim to create a cheap, disposable product that is intuitive to use and an add-on to current practice. Our interest is to create a device that is low in price but can sell at a high volume. As a group, we offer a solution that can remove the IO needle at low risk to the patient and provider. Some channels and revenue streams that we might utilize include licensing our patent to a medical device supplier, such as Medtronic, 3M, or McKesson. As word gets out to the public, we intend to expand our product into different hospital systems through advertisement and investors. Lastly, some of the expenses that come with this project includes outsourcing the manufacturing process, obtaining marketing streams, and other labor costs.
For our competition, the Luolock syringe is our strongest competitor because it is currently the most common method used to remove IO needles due to its simplicity. However, the Luolock syringe has unsafe exposure, excessive force, but at a cheaper cost per unit at 17 cents. Our solution, on the other hand, provides no needle exposure, ease of use, and immaterial cost relative to operation costs.
In terms of our financial projection, the device will cost us around $1 per device, and our selling price target is $10 per device, leaving us with a gross margin of 90% per device. We are looking to manufacture to all the hospitals in the United States in year 7, which each hospital purchases 300 devices a year, giving us a total revenue of almost $18.5 million. In year 1, we think that we are able to manufacture to 100 hospitals, where each hospital gets 300 devices, leaving us with a total revenue of $300,000. Hopefully, in year 2 and so on, the amount of hospital would double each year, leading total revenue to also double with it. Additionally, over the span of these 7 years, we are going to get a patent in Canada, China, and Europe. Also, in terms of returning investment, our exit strategy is to license our device to a medical product distributor, like Terrence mentioned previously, around year 3, because after 2 years of sales, we believe that we can value our product for about $4 million.
On to traction and milestones. Thus far, we have created our business plan. As previously mentioned, we have a working prototype and have done initial tests. We recently also filed a provisional patent. Our milestones in progress include final testing, which would be more clinical testing, obtaining funds to help us later on, filing the formal patent within the year, and hopefully making our first sales. In terms of investors and current needs, we estimate we would need at minimum $200,000. This would cover IP and legal costs, clinical trials if needed, manufacturing costs and labor costs, and marketing and advertising. We hope to get our funds through friends and family, loans if need be, crowdfunding platforms like GoFundMe, seed investors, and government grants. Thank you so much for listening. Any questions?
Excellent. Anybody got questions?
Tons.
Go ahead.
Go ahead, please.
Okay. Are you looking to have both needle insertion mechanism and extraction for the intraosseous injection?
Just removal.
Just removal. Okay. All right. And are there any, what I would say, downsides with removing the needle with a standard Luolock syringe? Are there failures or things that prevent them from getting the needle out?
There are some complications that happens when removing the needle.
Mm-hmm.
The needle has to be removed at a 90-degree angle. If
Mm-hmm.
not, that causes extravasation and sometimes cause a lot of problems.
Okay.
I'd like to add on to that. So if the needle isn't removed properly, it can sometimes detach from the plastic hub, leaving the needle embedded within the bone, and that can require excess surgery. And the needle can also bend if it's not maintained at a 90-degree angle, and our device eliminates those risks.
Okay. All right. Yeah, I wasn't fully clear on the first slide what your mechanism is. Some thought process is, this is definitely a 510K device. It's also going to be probably a sterile device, although you may be able to. You're only touching it. Yeah, you're communicating with the fluid path, and you might have you looked at, let's say, a lot of the bone biopsy needles and the way they're designed and some of the torquing handles that they have for access? I mean, there's a body of knowledge for getting needles in and out of bone.
So yeah, we definitely researched a lot of that initially when we created our device. I think the main thing though that we wanted to do was help eliminate that force with removal, because IO is very specialized specifically. You need to have that port outside and inside the bone. So we explored a lot of options, including just adding on to the way they currently insert, but based on feedback from clinical mentors, this was the best way.
Okay. Yeah. Okay. I wish you luck, Depita, Eric.
Yeah, I'm hardly an expert in this area, so but my question is more. You mentioned a competitor, Layer Lock, I think, and wanted to know how big are they? How are they everywhere? Are they just emerging? And what is
Lock is a medical thread used on hundreds, if not tens of thousands of devices.
I see.
So Rulox are fairly common in the hospitals, and their primary use does not lie in IO removal. So they're only used for IO needles because their tip was able to connect to it, and it was easy and simple for the nurses and clinicians to remove the needle that method.
I see. So then, can you describe to me in 1 or 2 sentences, when you go to pitch for the need of this, what do you say to somebody like me? Like, what happens today and what is this going to make dramatically better?
So the one thing that our device has over a Luolock is safety. It's the minimizing of the risk of the needle stick when you remove the IO needle. And because we minimize those risks, you will be safer. You won't have to go through other complications, and it'll be easy for the clinicians to remove the needle than using a Luolock.
So if I think of this as an improvement on current practices, right? It if what percentage of current extraction of the needle goes wrong? Is it 1%? Is it 10%? What is the compelling case?
It's around 96% success. So we have that 4% that happens with like complications and difficulties that comes with it.
And to add on to why someone would choose our device over an Lorlock syringe, for example, our device also allows for almost everyone to use in order to remove the IO needle. As we mentioned in the video before, removing the IO with the Lorlock syringe currently requires a lot of force, and we hope that, and we have data to back this up too, that our device minimizes the amount of force necessary to pull out the needle.
So, you're hoping that once the patent, I know you've applied for a provisional patent, but once the product is fully developed and the patent is done, that is proof enough to convince people that it's worth going for, to reduce that 4% to a 0 or a 1. And is, Bob and Derek, is 4% a very significant number? I figure yes.
I would say 4% is not a strong number. It's going to be a tough sale to convince somebody, to convince an organization to want to purchase this with only a 4% risk there. And you being the newcomer onto this marketplace, it'll be a really tough sell.
Yeah. I think your numbers of selling it for 10 when I can buy a 50-cent syringe to pull it out, there's a huge price disparity. My thought process here is I recently worked on a number of hemostasis devices basically for IV fistulas, some radial access, very similar type of device. You need to find a partner early on, and it's tough.
I agree.
You know, you're not going to sell this yourself. I personally had investment in a company in Philly, brilliant doctor, developed a hemostasis device. He sat on it for 10 years. He thought he could, you know, commercialize it himself. There wasn't enough scale or enough, what I would say, volume, overall volume or market size in the business. He's now, you know, selling it out to one of the big players in this. I mean, you can go to the Bards, the Bostons. That's not to say you can't be successful at it. You can, but this type of product, you have to work with a partner. You do need to make sure that you have your IP in place. And when dealing with these partners, and if you get to the point where you have a term sheet in front of you, make sure that you protect yourself against them sitting on it, because many times in the medical space, many good ideas get sat on. They get licensed for a fraction of the value with an upfront payment that seems very lucrative, but back end they sit on it because they just are happy selling what they have.
That makes sense. Thank you so much for your feedback.
Thank you. That was great. All right. Our next presentation, EOS Solar.
Hi, I'm Matthew Mullen, a mechanical engineering student at Stony Brook, and my senior design team has spent the past few months working on a low-cost parabolic mirror for solar power applications, such as desalination and energy generation, but the general design can be adapted to a variety of other markets as well. So this actually started out in 2019 as a project for the Innovated Hackathon, and the inspiration stemmed from some basic math. Over a fifth of greenhouse gas emissions come from burning fossil fuels for industrial processes like the production of steel, glass, concrete, and the desalination of water. Don't take my word for it, take Bill Gates. So if we're going to transition to renewable energy, and it looks like we are, we better use a plentiful renewable resource to replace the fuels we're burning. And from this diagram, it's clear that solar is the way to go. It's the most abundant form, and the price for solar energy has gone down drastically in the past decade. But logically, it doesn't make sense to replace the burning of fossil fuels with conventional solar panels for these processes, because solar panels are typically around 20% efficient at converting sunlight to heat. It makes much more sense to instead use concentrating solar power, which is essentially taking sunlight, focusing it to some light absorber like black paint, and converting that light energy directly into thermal energy. This can be up to 80% efficient, meaning that for the same output, you need only a quarter of the land compared to solar panels. It's also a lot cheaper and easier to store thermal energy in the form of molten salts or oils than it is to store electricity from solar panels in batteries. However, there's a problem. Concentrating solar power is somewhat expensive and requires a big upfront investment. Unlike solar panels, which benefit from modularity and economies of scale, concentrating solar power installations are typically massive and custom built. On top of that, the heliostats, or the mirrors that track the sun, typically account for about 40% of plant costs, in particular because they use fragile glass mirrors or heavy welded sheet metal structures that necessitate expensive high-torque motors. Now, some companies have come into the scene such as Heliogen, Skyfuel, and Cool Earth Technologies, but they provide imperfect solutions. For example, Heliogen's hardware suffers from the same cost issues as regular concentrating solar power plants. And while companies like Skyfuel and Cool Earth Technologies have used less expensive mylar mirrors instead of glass mirrors, Skyfuel ran into IP issues, and Cool Earth Technology seems to have abandoned their work, likely due to a combination of durability, efficiency, and cost issues. Our solution, after a lot of iteration, is this solar reflector that we filed a provisional patent application on. Like with other low-cost designs, it uses a reflective mylar mirror, but instead of laying the mylar on a piece of stamped sheet metal or putting it in a balloon, we put it on a low-cost, high-strength steel frame because the cost of a frame scales linearly while the cost of sheet metals or glass scales by the square. The frame itself is compact to ship, snaps together on site, and can be assembled without any welding required. We also designed the reflector such that when the mylar inevitably degrades due to abrasive particles or possible tears, it can easily be switched out, unlike other designs. Motors typically are one of the most expensive components in systems like this, so to reduce the cost, we we are working on replacing the actuators in the system with a combination of off-the-shelf motors and belts commonly found in 3D printers, smart algorithms, and non-backdrivable mechanisms to reduce the required torque. In the solar industry, one of the main driving factors for customer acquisition is cost. Cost per kilowatt hour of energy, cost of installation, and ultimately the levelized cost of energy. However, anyone who knows anything about business will tell you that you shouldn't compete based on cost, as it's a race to the bottom. And in a time where intellectual property doesn't get you very far, and where the ethics of ruthlessly defending a technology that could potentially have a positive humanitarian benefit are questionable, it's important to deliver something to the customer that goes beyond cost. And what we want to deliver to our customers is transparency, reliability, and an emphasis on robust software, which are often lacking in other solar products. Also will be based in the US, which is a requirement for most government grants. Our plan is to start in applications that require low temperature but are easier to manufacture while we perfect our design and keep our burn rate low, such as desalination and brine mining, and then move up to power generation and industrial processes like steel production that have bigger market potential. Therefore, we plan that our first customers will be small-scale desalination and wastewater facilities, as well as researchers looking for a simple and low-cost heliostat platform. We actually spoke to some potential customers in this area last semester while myself and a few other students were part of the NICRN I-Core program, as well as Dr. Pawar's and the Small Business Development Center's How to Build a Startup class. In fact, there's a competition going on right now funded by the Department of Energy to use solar thermal energy for desalination. I got a chance to speak to the finalists of this competition who are planning to commercialize their technologies within the next few years, but are looking for solar thermal heat providers at specific cost and temperature ranges while emphasizing reliability and US manufacturing. We'll be selling our initial models as kits for beta testing to individual users such as researchers, schools, and hobbyists, which would act as a multi-purpose heat source and would generate income and get our manufacturing up to speed. Based on the cost of materials, we think we can get the price of a single 2-meter unit down to less than $250.
Oops.
Pay-as-you-go strategy, where companies that need our heat source will purchase thermal energy for a fixed price, but we will own the equipment. While we have our design done and the parts ordered, we still need to finish the first prototype by March 13th and further iterations and testing by May 15th. For funding, we plan on doing the National I-Core program either this summer or this winter, which allots a grant up to $50,000 for customer discovery and small prototyping. All the while, we'll be putting an extreme focus on building a strong team. We're specifically looking to take on an industry mentor in the concentrating solar power field or in the desalination industry. Thank you for your time.
Thank you, Matt. Sorry for the hiccup in the presentation. I don't know what happened. Questions from judges?
Yeah, I go first. First one, easy one. Are you thinking to develop a product and that is the endpoint, or a way to get the concentrator, or are you thinking of making this into an ongoing business? I thought the former, but I'm clarifying.
Oh, you mean just like make it a product versus being a provider of energy?
Well, if you get the product right, like here is the right and viable way to do it, and then that is the endpoint where you either sell it to somebody who's going to manufacture it, etc. Because in order to make money in this, you have to have scale. So if you want to get into manufacturing, that's further down the road. And I was just thinking where your head is at.
Yeah, the idea is to partner with, I'm sorry about that, like partner with someone who has like a better manufacturing capacity. So whether or not that would be through Stony Brook or another institution like NREL that has like direct industry connections.
Okay. Second question, probably meteor. Okay. Like sort of gut feel, I feel like this has got to be a difficult thing to do, right? You're saying that 2 people were out there who have already either gone out of business or have, gone into something else. What gives? How are you able to do this or think about doing this viably? What's your secret sauce? Is it just technology? Have you uncovered something that no one else has calculated before? I know you talked about using metal versus using other materials whose costs are higher, but you may not be the first one to have thought about it. So what gives?
Yeah, so like as I mentioned before, the other designs they used, like this plastic reflector, just don't have an easy way of interchanging out the film. So like sand, and when you wash the film, it basically causes it to lose a lot of reflectivity. And a lot of other designs, they either like adhere it onto basically like a satellite dish, or they put it in like a balloon or something. But that makes it kind of difficult to replace the film easily. So my design basically just to, remove the film at nighttime if you need to, and swap it in with replacement.
Okay. Really easy question. Will it work in Texas freeze?
Yeah, probably.
All right, all yours, Bob or Derek.
It seems like your primary focus is on the mechanical engineering side and not any of the electronic side. Am I getting that right?
Yeah, well, like I'm eventually going to go more into the software, because that's where a lot of the other companies don't do that well in.
It seemed like you would have to work on, well, not even the software side, but I didn't see anything depicting about the overall electronics to drive the apparatus per se. And then there's a whole software component side to manage all the data or all the power that's coming in through your sensor, and how you would feed that back into the grid per se. Have you thought through that?
Like just the electronics that motors around and stuff?
Mm-hmm. Correct.
Yeah, that's it's like pretty simple, because it's just like stepper driver circuits.
Okay.
We have like the electronics done for that, but we're still like in the prototyping phase. We haven't actually built a prototype yet.
Okay, fair enough. You can go ahead, Bob.
First of all, gentlemen, I would say wonderful presentation. The delivery was nice and the messaging was clear. You're to be applauded on that. I'm a biotech guy, but ironically, in the COVID time when I had some downtime, I do follow a lot of green energy companies, and I follow about 40 of them very closely. And one of the things I notice about a lot of these green companies, they have very high market caps, and their finances really don't support their market capitalization that much. But the one thing that is very interesting is, to Derek's point, there's some amazing inverter technologies coming out for electrical power, particularly off of solar panels. I mean, there's some really wonderful stuff coming out. And I think in this business, you got to go big or go home. The one thing that, this is like a comment, and I don't know about it, but in the 40 or 50 companies that I follow very closely, there's not one that talks about desalination in water. Obviously, clean water is a big problem. Accessibility of water in many parts of the world is challenged. And quite frankly, in developed places, it's going to be challenged. We just consume way too much water. So I'm going to say is, yeah, I get the desalination with a hot solar, heat source. What I would say is, does it kill microbes too? Or can it kill microbes? Or can you make some kind of quote unquote desalination / purification for water? I don't know much of, there's a lot of people chasing electric and with all different shapes and forms, but I've yet to find one in all these stories that are following water. So that was the thing that stuck out in your presentation. I chase it. I don't know what's out there competitively, but it sounds like you might be onto something.
Yeah, and the desalination idea is really good because there's a huge demand for it in the developing world. And if we can make an affordable way to do it, there is plenty of sun, but not an affordable way to do it. You should look into like companies in Israel that are doing this now. I know they keep it very secret, but
Yeah, I actually got to. Oh, sorry.
The last question I got for you is, what is the overall size of your device, and what's the footprint of it?
Yeah, so the prototype we're making is about like 5.5 feet in diameter, and then it comes off the ground also 5.5 feet. And so that can make about 1.5 kilowatts of power for heat energy.
Okay.
But
And what is your projected cost to make a single? You know, when you get into production, what are you anticipating your projected cost to make it?
Yeah, so it's like all kind of estimates I mentioned before, but the goal is $250 for like a 1.5 to 2 kilowatt unit. Although like it does scale pretty well because the most expensive parts are the motors.
Okay.
But yeah, I actually spoke to some people in Israel who work in IDE, which is a desalination company, and they said that this would be good in like not the primary desalination unit, but to recover more water from basically brine that is produced in the desalination process.
That's great. Good job, Matt. Thank you, everybody. Now we're on to our next presentation. Sense. Let me bring it up. 1 second. All right, here we go.
Hello, everyone. My name is Dan Mahoney, and today my business partners and I present to you SENSE, which stands for Collection of Evidence and Notifications for Transport by Stretchers. Our motto is that pennies of data add up to discovery. When we asked approximately 50 of the 265,000 EMTs and paramedics in the US, what we found was emergency stretchers have a ton of issues. Things we heard were stretchers are bulky, they're awkward to maneuver, and worst of all, they can even cause falls. A wheel catches on a crack, and all of a sudden the patient is tipping over and the EMT is straining a muscle. From 3 years of experience as an EMT, I found all of these to be true. When we refer to the literature, the same things can be found and more. Specifically, though, there is a lack of information regarding the exact science of these falls. There is a major lack of standardized training on how to actually operate a stretcher in the field. With our device, we hope to not only increase the amount of data that is collected, but we aim to use this data to both inform and protect our patients and providers. According to the National Institute for Occupational Safety and Health, there's an estimated cost of $34 million for about 21,000 injuries in 2014, and this doesn't even scratch the surface of medical malpractice costs when a patient is involved. For EMTs, paramedics, patients, and the researchers of the emergency transport sector, SENSE is a practical and upgradable tool for actively improving the way we transport patients via stretchers. At the push of a button, this device will begin to record and analyze data, providing real-time support in the form of LEDs, haptics, and even audio commands to providers who are unsure of how fast or how high to be traveling with a patient. SENSE will store and export HIPAA-compliant data at the push of another button at the end of transport. And because of this, researchers and engineers will be able to accurately examine and use data that was never before available to inform standards of care. For a monthly subscription of just $15 per month per device, we can aid in saving millions for emergency medical services.
We have successfully outlined a plan to have SENSE completely developed and fully protected by the end of 2021. Our prototyping process relies on inexpensive, open source, easy to obtain hardware and software. In addition, we have ample access to all mechanical prototyping necessities, such as high-resolution 3D printers and laser cutters. To date, we have completed a wired design of all base features of SENSE, and we are in the process of creating a versatile wireless design that is incredibly easy to install and maintain. We have also begun the process of obtaining IP protection for our design and have formed partnerships with Stony Brook Hospital and Port Jefferson EMS Agency to make testing SENSE an absolute breeze.
The device will be introduced into the U.S. emergency medical services products market and obtain recognition by endorsed by the National Assembly of Emergency Medical Technicians. considering they are advocates of providing high-quality education that improves the knowledge and skills of practitioners, as well as supporting EMS research and innovation. Secondly, we would present at medical device or EMS conferences through product demonstrations. Some include EMS World Expo and JP Morgan Healthcare conferences. Finally, we would campaign digitally through websites highlighting tests completed on recognized stretchers and focus on its novelty and multi-purpose. Sense will be released to the public as a subscription-based service. We will distribute our device to subscribers for free, but charge $15 per month for access to the data backdrop available to each user. This is possible because Sense will continue to supply researchers with data for years and ensure provider and patient safety. Also, considering our device's minimal obstruction to transportation and the typical service life of stretchers being 5 to 10 years, we expect Sense to bring an ongoing stream of revenue. As for acquiring a quality device, Sense will partner with manufacturers to assemble parts costing $93. After 6 months, we will cover our cost of goods sold. As for attracting stakeholders, we would follow the strategies previously mentioned to meet hospital administrators, EMS chiefs, and stretcher companies.
So for competition, our competitors are surveys, which are done annually by NAEMT and the Stryker Power Load, a device that assists in the loading of stretchers. For affordability, Sense with its subscription model and surveys, which are done for free, fulfill this criteria, while the Power Load suffers from a high cost of $20,000. For frequency and objective data, our device remains uncontested due to collecting high amounts of quantitative data per second, while surveys are highly subject to bias along with being conducted once a year. On the other hand, the Power Load does not even collect data. For setup, Sense has few parts that require minimal setup onto the stretcher, while surveys take a while to organize and the Power Load requires immense structural changes on the ambulance to accommodate for it. Lastly, our device Sense also contains safety features, a trait shared with the Power Load, but not with surveys.
This is our financial projection for the first 5 years of our product. We don't expect significant revenue in the first year as we perfect our manufacturing, design, and marketing techniques. But we're going to produce 100 devices per month at $93, which leaves us to $111,600 per year for cost of sold goods. R&D will be at its highest and slowly decline as the design becomes more refined. Our wage expenses will cover hiring personnel for testing, one example being hiring electrical engineers to evaluate the safety of our circuits. We don't expect to advertise heavily in the launch year until after our packaging, market plan, and design are strengthened, after which we'll advertise on multiple platforms like website ads and TV commercials. Only after our spike in subscriptions in the second year, we would decline advertising.
We are proud to say that the design of Sense is not just an unproven dream. Sense has gone through rigorous product validation by a multitude of medical device professionals, biomedical engineers, and EMS operators. Coupled with our vast prototyping progress, Sense is well on its way to being field tested, submitted for IP protection and FDA approval, and propelled into the EMS market.
We are currently provided resources and workspaces at Port Jefferson EMS and Stony Brook Medicine valued at nearly $10,000. Strikers note that Sense may support performance measurement in the field. Insurance companies can use our device to make educated coverage decisions, and we have even begun applying for EMS research innovation grants. We currently have a $1,000 budget from the BME department, and if we were to win this award, we will use the money to purchase more powerful sensors as well as legal assistance.
Awesome. Judges, questions?
I do have questions. My first question is basic. Are there companies, are there only a few or many companies that make stretchers that are used on the EMS, the ambulances and such? And if yes, have you talked to any of them to see if you can directly go with them and put the sensor on?
Dan, do you want to answer or somebody else?
Hello, I'll answer. So we have reached out to stretcher companies on validating this, and our device will not be voiding any warranties, considering our device is not going to change the orientation of any position of equipment on the stretcher itself.
I'm sorry, I have some background noise here. Could you repeat the question for me?
Yeah, my question originally was, in this business, are there many companies that make stretchers, or are there just a few? And it's like, Windows inside the computer model. You can have the sensor built in with the stretcher versus having to put it on. That could be one way. And I'm just thinking if that's a possibility.
So there are multiple companies that develop stretchers and perform testing on them. In our research, we discovered about 5 of these, and 3 of them are operating in the US. Specifically about the adaptability of the device, we are looking to develop an MVP that solely records data on the stretcher. Moving forwards, we would like to partner with these companies to record and analyze this data in a way that we can develop the device further for future iterations. Those future iterations would include the notification procedures that will require the rigorous testing moving forward. So as you can understand, the device has future iterations that we will need more testing in order to actually market those devices.
Right. Okay. 2 more questions. One, and I'll say both of them out. One is, what is the current procedure today when, how often are stretchers like maintenance done? Is it every day? Is it not enough? That's one part. And I'm assuming that the breaking down of the stretchers is related to wear and tear and not manufacturing defect for the most part. The other one is, have you thought about technologies that cue into preventive maintenance? And is that the direction you're going? So for example, how subway doors sometimes don't close, and you put in some kind of an AI bot there that signals that maintenance is needed, so that before the doors break, there is maintenance that is done. Just wondering if any of that has been explored by you.
Yeah, so that's exactly the direction we're headed. So if you look into the longevity of the stretchers, it's about 3 to 5 years. As new stretchers come out, EMS agencies tend to upgrade. Along with those upgrades, we have to follow and perform our own upgrades. So as the EMS research sector moves forward, we see that there's increasing need for data. These stretchers are designed based on the manufacturer's own performance standards, and there is no standardized data being recorded for all of the manufacturers. So that's what we're hoping to go for.
Okay, and if you maintain the stretchers more, you're going to sell less stretchers. Have you thought about that?
Well, to add on, we're not exactly selling stretchers. We're selling a device add-on, an assistive device to stretchers. Yeah.
Yeah, I understand. The stretcher companies may not cooperate with you if this kind of maintenance makes them sell less stretchers, is the question.
I see. Well, one of the main goals of our device is also to provide real-time feedback, not only on the structural integrity of the stretcher, but also on the practice of the EMS providers. For example, as Dan said in the presentation, recommendations on the height of the stretcher, recommendations on the speed, alerts about possible erratic terrain, about the integrity or the whether or not certain safety latches are in place. The device is going to be able to monitor those things in real time and provide recommendations to operators to keep patients safer, not only just because of the structural integrity, but also during the entire transport process.
Okay, got it. Thanks.
How are you going about with structural integrity of the stretcher? What are you doing there to do that without revealing any trade secrets?
Yeah, that's a tough one because we do not currently have a provisional patent. There's not much we can disclose on that. What we can disclose is that it's going to monitor certain interactions between the ambulance and the stretcher that could potentially prevent patient falls, and it's going to monitor a hardware connection between the ambulance and the stretcher that could prevent patient falls in the loading and unloading process. That's the main structural integrity point that we're going for. as far as like the wear and tear on the wheels, things like that, that's a tough one that we can't exactly, or we don't exactly have a solution for, but that I guess wasn't our original intention.
So if I understand properly, you take, and this is way out of my league because I don't do anything with stretchers. If you have a stretcher, you're going to sell a kit to a stretcher manufacturing company. That is the end. Your target customer is the manufacturer of the stretcher, or is it the EMT, or is it the hospital?
So our target customer would be the EMS agencies that will be utilizing the device. We can look into partnering with a manufacturing company, a stretcher manufacturing company, and we began talking with Stryker. What they say is that they believe the device can enhance their performance measuring, so that when they put these stretchers out, they can provide feedback they can get feedback on how their device is performing. And specifically, maybe structural integrity wasn't the correct word to use. I'd say more so the integrity of the transport, if it's going well, and how the parameters that we're monitoring are being affected. So specifically, I won't go into the details of those parameters because those are what are trade secrets. But the actual parameters that are being measured are the ones that are concerned parties, let's say.
So your go-to-market strategy, if you had to pinpoint it, your first level of attack per se, is to the EMS providers or to companies like Stretcher?
So first we have to verify that we're not getting in the way of anything that the stretcher companies are doing. We have to make sure that there are no concerns in licensing, but then our target customer would be the EMS agencies who have the funding to actually buy the device and use the device.
Okay. I would just sort of look to spin that around and work with the stretcher companies. This way you sell to a few and then they resell your product to the EMS agencies, versus where you have to go out to each individual agency and prove yourself. When these stretcher companies already have the market, they know what they're doing. Just be a faster road to revenue.
Yeah, one potential idea we had was having the actual device itself sold to the stretcher company. They manufacture their stretchers with the device and they market their stretchers to EMS providers saying, hey, this is a subscription-based service that will provide you with data. And on our end, we gain the monthly subscription fees, and we also upkeep the data, maintain servers where EMS providers can go back in and look at this data and look at this data in post and either use it to bolster insurance claims or bolster training or things like that. So we did have the idea of selling the device to a stretcher company, having them manufacture and install the device. That would cut down our costs drastically. So we'd be responsible then for data upkeep, which is, I'd say, less costly than manufacturing.
Who I know in one of your slides you talked about your competition. You said one of them was like a survey. Can you expand on that some more?
So essentially, we like every year at the organization NAEMT would conduct surveys among their EMTs to check on like things like operations and safety, and to check on the competition of our device. Our closest competitor were those surveys themselves, because there's currently no add-on on the market that's capable of measuring data the way our device does. So the closest equivalent were surveys instead.
I see.
I would also like to add that some of these National Registry of EMT or EMS, they do conduct their own research as well. So they would also reach out to providers asking for surveys or questionnaires. And this would also be accounting for those type of situations.
Okay, thank you.
Just one quick question. Are any of the team members an EMT?
Yes, that is me.
Okay, so that's great. So you obviously can articulate the pain points. I'm hearing two things: patient safety and EMT safety, and probably EMT convenience. So, I think being an EMT, you can almost validate your own designs. Obviously, you want to reach out beyond the universe of one. To put a bunch of sensors on and collect data without a purpose, I think the best devices are simple. I mean, if it's something you can clip onto a rail of a gurney or a stretcher that would better balance the load. I'm just speaking hypothetically, particularly when they put patients of different sizes and they put all the instruments and oxygen bottles, which I'm sure as your EMT, you see all the time. If they can do a better job of not having the gurney tip or bang or hit somebody, I mean, I think would you want to distill it down into like a quantifiable benefit to somebody? I think the EMT and, obviously patient safety. I don't think most patients really want to be on a stretcher under any circumstances, but they just want to be on it for the shortest period of time in the safest manner. So, I think it's great presentation, but I think you need to communicate that in your pitch a little bit better.
Yeah, so to keep it short and sweet, those 2 points that you made are correct. And I'd say that there's one additional point, and that it's all of the research that we have and all of the documentation that we have is qualitative. When it comes to emergency stretcher adverse conditions, we don't exactly have any data that we're collecting. We're simply reporting it based on our own reports, like it's all verbal. So the Office of the Inspector General reported in 2012 that an estimated 86% of hospital incidences go unreported. So the only way to do this is to record data anonymously and immediately. So if we could just press a button at the beginning of transport, there's no need for the provider to weigh in on things when it's just being recorded anyways. I think that would be a very beneficial way to, clear out any biases in these reports.
Okay, very good, gentlemen.
All right, thank you guys. Good job. Next presentation is ultrasound simulation. Let me bring it up 1 second.
Hi, my name is Alex Eichert, and I'd like to introduce my colleagues, Thea Vijaya Kumar, Daniela Aber, and Griffin Walker. We are part of the Medical Device Innovation Clinic, a multidisciplinary team of medical professionals, master's students, and undergraduate students across majors. Today, we are so excited to propose a cost-effective, portable, and realistic ultrasound training tool for hospitals and first responders, Hocus Pocus, or point-of-care ultrasound.
In an emergency, one mistake can cost a life. The use of ultrasound imaging in hospitals and ambulances can drastically change the outcome of care, from changing hospital destination to enabling earlier treatment. For example, one study showed that 30% of collapsed lung cases, like the one in the picture, were initially misdiagnosed, leading to further complications. Mistakes like these emphasize the need for effective ultrasound training. Current training technology is expensive and designed solely for hospital environments. However, ambulances are where over 200,000 first responders in the U.S. work. Our aim is to create a cost-effective, portable, and realistic ultrasound training device for hospital providers and first responders. There are three main issues with current ultrasound training devices: failure to account for ambient motion in ambulances, unrealistic user experience, and cost. Ambient motion issues mean that current technology is incompatible with moving environments. We plan to address this by isolating probe movement from the ambulance movement. Our current design accounts for tilt, orientation, location, and pressure, and a lower price point will come from using more cost-effective materials. On the right is a mock-up of our product with a probe, software, and pressure mat to be used with a mannequin or volunteer. We are focusing on the hardware aspects of the product initially, and plan to incorporate simulation software later in development.
Over the past 7 months, our group has conducted extensive background research on competitors, related patents, and design requirements for our device. As you can see in our development timeline shown in the figure, we're currently in the beginning of our iterative design and prototyping phase, where we are testing multiple methods of pressure sensing, mechanical design, and software integration. We'll then move on to the testing and patent process by using the resources available to us through the University Hospital and the College of Engineering and Applied Sciences. In terms of marketing our product, it's important to identify the two main consumers of medical simulation and training devices: hospitals and paramedic or EMT programs. Volunteer and low-budget programs are particularly important to target because our device will enable them to train more healthcare professionals at a more affordable cost. We plan to reach these groups by contacting simulation centers, distributing samples, attending conferences, and publishing in journals. Our business model will offer two purchasing options to provide more flexibility to consumers. The first is a one-time purchase of the probe and other hardware, plus access to the lung ultrasound library at no additional cost during the first year. Yearly subscriptions will be available as we expand to other downloadable modules such as cardiac and OBGYN ultrasound. This allows us to keep initial prices lower instead of requiring a larger fee upfront. Option 2 will allow groups to rent the hardware and desired software modules for a limited time period, for example, for a large training class. This allows programs to choose the better financial option for them and sets us apart from competitors.
Although we have multiple competitors, none prepare users for the challenging circumstances faced by first responders. Most are designed to function in a stationary environment, and image quality suffers in mobile conditions. These devices are typically expensive, ranging from tens to hundreds of thousands of dollars. Furthermore, the equipment requires bulky computer setups with constant internet connections which are not portable or practical for ambulance use. Finally, simulation requires a realistic experience. Competitors attempt this, yet their images often lack the fluidity of clinical ultrasound, acting frame by frame rather than as a continuous video stream. Hocus Pocus fulfills a critical need for a more accessible and affordable ultrasound training experience. The overall medical device simulation market is currently estimated at $4 billion and is expected to double in size by 2025. Our current projections show an exponential increase in profits during the first 3 years as we improve our manufacturing and marketing efforts. We predict a large number of our sales will come from rentals, and we are confident many renters will eventually purchase the full product. Rental estimates are based on the assumption that the devices are used multiple times a year. We estimate a profit of about $300,000 in the third fiscal year.
Our team is part of the Vertically Integrated Projects VIP program and is centered around designing solutions to medical problems with a diverse collaboration of disciplines spanning medicine, computer science, and engineering. In the spring of 2020, we received a seed grant to conduct research into developing technology to aid physicians in combating COVID-19, which eventually grew into a fully designed intubation chamber to protect physicians. We subsequently published our work in the Annals of Biomedical Engineering, a widely renowned journal, and were recognized nationally by the VIP Consortium. During this time, we grew together as a team and expanded our resources. We are so confident in our ability to succeed in this current project. We have compiled an itemized list of initial materials and resources required for our prototype. We estimate that around 10 iterations of our prototype will allow us to develop a market-ready product. However, we will encounter additional costs beyond those outlined for the prototypes, including those required for marketing and obtaining a provisional patent. We plan to pursue multiple avenues for external funding, such as the SUNY Research Seed Grants, SBU programs like Eureka, and the National VIP Consortium. This device isn't simply an academic project. It targets a real problem that affects real people. Investment and mentorship from the judges here tonight at WolfieTank would be instrumental in helping to train the next generation of frontline heroes. Thank you so much for your time. Here are references. And does anybody have any questions?
Great presentation. Thank you, guys.
Yeah, very good presentation. It looks like it's a tradition that I always go first, so I will. A good presentation, and I wanted to ask, so are you focusing in on the particular problem of accurately getting an ultrasound inside an ambulance or a moving object, or do you have a bigger use case?
So we're trying to get more simulation technology so people can use ultrasounds in actual ambulances. So the current technology is only for stationary environments, things that don't move, because they typically interfere with calibration. So that's like the market that we're going for, and we don't really have competitors because they can't use their devices in an ambulance.
Okay. Follow-up question. You said that you're first going to focus on the hardware and not the simulation part of it. Explain that decision, since that seems to be your point of difference.
Sure. So we're focusing on the hardware part because we want to figure out how to deal with the probe design with the tilt orientation and all of the pressure components combined. And then we're focusing on acquiring the actual ultrasound images as well as putting everything together. So first, the hardware is the easiest part to put together, and then the software comes after.
Okay. And as you think about, you coded like a 30% error rate in like lung cases, I think you said. All of that is because of the technology, or are there also human errors involved there in terms of detection? Because we've done some work back in my past role where we were looking at incorrect even detection through radiology kind of work, whether it's tuberculosis or brain tumor and things like that. So what is that percentage in that 30%?
Sure. So there was a study conducted where people were tested to see if they had a lung condition or collapsed lung. And there are different levels of collapsed lung cases. So some physicians weren't able to detect it in about 30% of the cases, and then it developed further into more severe lung collapsion.
So when it's a simulation, is your simulation to be able to read, like are you using lots of training data and training the model to detect it better, or what is simulation in this case?
So simulation means just showing what an ultrasound, like an actual ultrasound would show you if a patient had a specific condition. We can't train on specific patients because you won't be able to see the different conditions, especially in rare cases where people need to be treated immediately. So a simulation allows you to have the ultrasound effect without having the exact patient there, as well as like dealing with real life situations. It's just a simulation to show you what it should feel like.
For the purpose of training the users.
Exactly, yes.
Okay.
So that pad, you basically put the transducer on that, and that pad has digitally feedbacks into a specific exam, be it looking at a kidney or a liver or something, something of that nature, a thyroid.
Yeah, so we're focusing more on the torso portion of the body. We will be able to put it on a mannequin just as like a dummy to give the effect of actually having a human. And then it will give feedback based on where you are on the specific body. It'll show you different images. And if you want a specific condition, it'll show you that on the computer.
So you could take that pad and conform it to an anatomical model. Good. I think I'm sure you're well aware of butterfly networks out there. They're selling a boatload of those things. And there's a lot of people running around doing ultrasound that probably shouldn't be, and they probably need training. So you might have something there.
So there is a big need, I guess, and again, out of my league, for training on an ambulance on the go, I guess. You're telling me that EMT workers are not properly trained as they're on the ambulance. Is that the scary fact?
So the scary fact is that the United States is kind of behind compared to other countries who have been using ultrasounds in ambulances prior. And there have been a lot of case studies that show actually having an ultrasound in an ambulance can help you figure out a condition faster and provide better results for the patients. So since the technology was so expensive, people wouldn't be able to train EMTs or paramedics to use it. And especially since the technology is only for stationary positions, you can't really change the orientation or anything because you'll get different images and it won't show you what it actually would be like in an ambulance. So now since the Butterfly IQ came out and it's very cheap, a lot of people are now incorporating ultrasound technology, which is why we need a simulation that's cheaper for people who have like less of a budget.
Fair enough. Very good. You did a very nice job on your presentation. And what I also like that your team is also little small things. You're all in sync with the same background, that's a plus. So when you present that comes across, you guys have your act together, and I appreciate that.
Thank you.
Any more questions from anybody? All right, great job. We're going to take a quick 10-minute intermission so we can review the scores, talk to the judges, and then get back and tell you who won the competition this evening. See you all in 10 minutes. Hello, everybody. Welcome back. It's a pleasure to see everybody. And I hope you guys are all doing well and have enjoyed WolfieTank so far. I want to again thank our sponsors, Solder Technology, Softeon, IV Matters, Balsamic, and Markham for all their support. The judges have deliberated, and I'm here to announce the winners. I can't believe how fast that went and how exciting the whole event was. You guys all should get a round of applause. Great presentations. We all thought they were awesome. And everybody loved everything you guys did. So great job, everybody. So the first thing I'm here, we're going to announce the Best Social Entrepreneurship Award. That goes to Active Site. Great job, everybody. Congratulations. The second place winners of tonight's event is EOS Solar. Great job on that presentation. And the first place winner of tonight's presentation is Ultrasound Simulators. They loved it. Great job, everybody. So you guys did awesome. We were so pleased with everything you did. We want to thank you so much for everybody who participated tonight. And we want you to save the date for the future for the next one coming in November. Great job, everybody. Winners, please reach out to me and I will talk to you soon. Thanks for coming to WolfieTank 2021. Good night.
Good night. Thank you, everyone.
Thank you. Good night.
Good night.
Good night and congratulations. Jobs well
Thank
done.
you.